Work. The meaning of work in everyday life is very different from the meaning of work in physics. When is work said to be done in physics? Work is done when two things happen. One, a force is applied, and the point of application of force suffers a displacement. That means the object on which the force acts has a displacement. So only when both things happen, work is said to be done. You have to have a force and there must be a displacement of the object on which the force is acting. So then work is done by the force. The work done is measured as a product of force times displacement times cosine theta, where theta is the angle between the force and displacement. Let's explain this formula. We know that the more force we apply, the more work we do. And then the greater distance you have to push the object through, the more work you do. So that makes sense. So why is that cosine theta factor there? So say for example, you have a box on the floor and you have a rope tied to it, and then you are pulling this using a force applied along the rope, which is at an angle to the horizontal, and say that angle is theta. Now this box on the floor moves horizontally, so this is the direction of displacement. Note here that D represents the displacement of the object. So if you look at the situation, all of the force is not resulting in the displacement. You can split the force into components, and we are interested in the component of force that is parallel to the displacement, and we know that that's going to be F cosine theta. And it's this F cosine theta that is responsible for this displacement. That is why work done can be defined as the force component in the direction of displacement, which is F cosine theta, times the displacement itself. So that is your general formula for work done. So let's look at special cases. What if I am pushing an object this way and the displacement is also in the same direction? Then what is the angle between the two vectors that are in the same direction? That will be 0. So therefore work done becomes force times cosine 0 times displacement. Cosine 0 is equal to 1. So therefore work done becomes simply force times displacement. In fact, this is the maximum amount of work that is done by this force in producing this displacement. So when force and displacement are in the same direction, you do the maximum work, and it is positive work that is done by the force. What if there is a situation where you are pushing the object this way, but the object is moving in the opposite direction? How is this possible that the object is moving to the left while you're pushing to the right? Is that really possible? Yes. What if the object was already moving? Let me give you another situation where you can easily understand how this happens. Say you're on a slope and there is a boulder that is moving this way, and you are trying to stop it by applying a force this way, but you're not able to stop it. So that means you're pushing forces this way, but your velocity and therefore the displacement is in the opposite direction. In which case work done is going to be force times cosine of the angle between two vectors in the opposite direction. Force and displacement is going to be 180 degrees. So cosine 180 times d. And cosine 180 is negative 1. So therefore work here becomes negative F times d. In fact, this is when you do the most negative work. So work done can be positive or negative. What is the difference between doing positive work and negative work? When work done is positive, it results in increasing the energy of the system. For example, we know that if you apply a force in the direction of motion, then the object picks up speed and therefore gains energy. If the work